Okay, so let's have a little look at reading off gauges and graphs and things like that. So as before, have a read, pause the video, see what you think, and then you can listen and see the solution I come up with. So we've got a pressure tire for for bike tires, I think it was, yeah, tire on his bike. To highlight the relevant information as well, that's between this and this, so that's safe. Okay, PSI. Okay, he blew up his tire to that to determine if it's safe. So on this gauge, we've got two separate readings. We've got PSI and we've got KPI, so pounds per square inch and kilopascals. On the outside, that's the PSI because the writing here is on the outside. This is on the inside. So let's have a look. 230, where's that going to be? Well, to work out what each of these increments are, look at the total number divided by how many increments. So from 200 to 300, I've got 100. It's gone up by 100. And there are 1, 2, 3, 4, 5, 10 gaps. So each one is going up by 10. And you'll see here there's a slightly bigger one to show you that's the halfway point to help you count all these. That's going to be 250. So 230 is going to be in here. If I was to draw a line like that, along there. So if it says, well, what is, is it safe? Okay, well, the safe range is between 35 and 45. The safe range is over here, 35 and 45. I'm sure I've got my tires a lot higher than that, but right. I've got mine up at like 90 or 100. maybe it's more. This could be more mountain biking. I think biking now. 35, 45. So he is just outside of the safe working range. So I would say it's unsafe or unsafe, as I'm writing there. It's unsafe because, just say this bit so you can see it, because 33 is less than 35 to 45. Maybe say something like that. I think that would suffice as an answer. Yeah, 33 is less than 35. That would be, So you could compare it for you could also, turn this into KPA. You could have gone the other way and said, well, that's my safe KPAs. So that's about, what's that, 240 KPA safe, versus 230. You could do that if you want as well. So yeah, easy peasy. Laura's got to inflate her lorry tyres to a pressure of this. Mark this on the gauge. So 84 psi. So again, psi is on the outside and kPa is on the inside. We're looking for 84 psi. 84 psi. So this is quite a funny gauge. It's going, how far is that? It's going 30. Okay, going 30. And I've got 1, 2, 3, 4, 5 divisions. So each division is worth 6. So I'm trying to get to 84 now. I can look. You could label all these up if you want. So that would be 66. That one would be 72, 78, and 84. Or you could have just said, well, 90 take away 6 is 84. We first step is to break all your bits up, and I will call that. I'll go down here. That looks like that one to me. I'm not wildly clear what each of these are, so let me just have a look. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I'm kind of struggling to see the. Yeah, it's quite tricky to see the. I would have thought they'd be going up. It kind of looks like that belongs to 200. Kind of looks like that one belongs to 400. Just check if that's nice and even. Well, it doesn't matter. I think they would have made that clearer if they were wanting you to use that. All they want you to do is mark on the 84. So, looking at this, yeah, it's not very clear what those numbers are, but they've been a bit lazy there because you don't need this. This is just really thrown in to confuse you. All you need to know is that the PSI is up here and your total mark on 84 stuff. This one, Jillian thinks that 24 Fahrenheit is colder than 3 degrees Celsius. Determine if she's correct. Okay, well, let's just mark on 24 Fahrenheit and negative 3 Celsius. Here's a Celsius. So again, you've got 10 increments going down 10 degrees, so each one's worth 1 increment. That's quite easy. So there's negative 3 in there, negative 1, 2, and 3. So there's negative 3 degrees Celsius. And the Fahrenheit is 24 Fahrenheit. So this one's going to go up the way. This one we've got 1, 2, 4, 5 increments. I'm going up 10, 5 increments. So they're going up by 2. So 24 is this one, 24 degrees Fahrenheit. So which one is colder? Well, the top is the hot, the bottom is the cold. So 24 degrees Fahrenheit is colder. So is she correct? Jillian thinks it's cold. Yes, so she is correct. 24, yeah, is colder than -3. And if you mark this on your diagram, that would go as proof. Stuff. Again, have we look. So we're told that the outside temperature is 34 degrees lower than ground temperature. So outside temperature is 34 degrees lower. The ground temperature is 6. Calculate the outside temperature and mark it on the. Okay. So the outside temperature is 6 degrees. Sorry, the ground temperature is 6 degrees, and I'm told that the outside temperature is 34 degrees lower than that. And so if I take off 34 degrees, that's going to take me from the ground temperature to the outside temperature. So what is 6 take away 34? Well, let's just do a wee number line. If I take away 6, I get to 0. So what else do I have to take away to make sure I'm taking away 34 in total? I'm going to have to take off another, what would that be? 26. Right, 28. Because if I take off 28 and 6, that's 34. So it's going to bring me down -28 degrees Celsius. So your outside temperature is 34 degrees lower than ground. So I've gone from a ground temperature, I've gone down 34 degrees, bring me to my ground temperature. Sorry, outside temperature. And then we just mark it on. So I've got -28. So the inside is Celsius, the outside is Fahrenheit. So let's have a little look. Celsius, I'm over -28. So it's going to be somewhere in here. But what is the value of each of these points? Well, I've got 0 to 20, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 20 degrees, I'm moving 20 degrees, and there's 10 of them. So that's 2 degrees for each. So to get 28, I'm going to go 20, 2, 4, 6, 8. It's going to be just in there, -28, which makes sense because that one, the dark one, would be bang in the middle between these two, so that'd be negative. So just a little bit, just again wordiness. I think that's about just the way they're saying that. To try and visualize what they're saying, it's a bit of a kind of horrible, you know, way they word these questions. I think to deliberately make it confusing. The outside temperature is 34 degrees lower than ground temperature, but just your ground temperature is this. You're going 34 degrees below it, and then you're looking at your readings. I've got time for one last one. That's more of a fractions one. Okay, I'll quickly try and do this. We'll do this one I've got. So we read. Okay, so his car can hold 64. So I know that there's 64 in there. Colin started with a full tank and used 40 litres. Where's that going to be? So I know I've got 64 as full. I've used 40, so I've now got 24 remaining. Now let's think about what each of these little bits mean then. Okay, so that's 64 litres in there. Half of it would then be 32. So I've got 1, 2, 3, 4, 5, 6. I've got 8 divisions, and there's 32 litres. So 32 divided by 8 is going to give me 4. So each of these divisions are worth 4 litres of fuel. And I want to say, well, I've got 24 remaining, so where's 24 going to be? Well, 32 take away 4. That one is 28. Take away another 4. That one is my 24. So I'd be pointing to this one. Well, you just do a quick check and count them 4s. 4, 8, 12, 16, 24. Was that in check? Obviously missed out 20. 4, 8, 12, 16, 20, 24. There we go. It's getting late, or should I say it's getting early. So yes, that's your classic. Look at how much you've got divided by the number of divisions. I'll quickly do the same for this. I won't talk through it, I'll just show you the answer. So how about we try this? So yeah, if your full tank's 280, half the tank's 140, therefore a quarter tank 70. Each of the divisions, 70 divided by 2, add on your 35, 105. So can she make it? No, she can't.